Okay, guys, so today we're going to look at functions and some object-oriented programming. That going to be a very important concept in what we're doing. And so we need to get started on this as quickly as possible because it's a thing that you really need to grasp if you're going to do any kind of development. Excuse me, today it's very important that you understand the concept of object-oriented programming. Object-oriented programming, in a nutshell, kind of as a rough definition, is the mindset of programming, or the model of programming, where one models real-world objects with software. So if you're going to write a program about like an adventure game, then you might have characters as classes, and you would have monsters as classes, and you would have objects, weapons, and potions as classes, and things of that nature. So essentially, that's what we're going to start learning today, is how the concepts of and the requirements for object-oriented programming. One of the things that first we need to get our heads around is the concept of classes. Think of a class as a blueprint for objects. So let's say I'm writing a game and I want to have a sword as a weapon in my game. Now, I can have a lot of different swords. I can have magic swords and not magic swords and short swords and long swords, all kinds of swords, but they are all fundamentally swords. And so what I would have is a class called sword. And at that point, then, I would have parameters within my class that define the sword. So I could have magic swords and long swords and short swords. All of them would use the same class. They would just have different parameters. And from that class, then I could create specific objects. I could create a magic sword by setting the magic parameter in my class to true, say, for example. Or I could create a long sword by setting the length class, or the length parameter of my sword class, to long. Or I could create a really powerful sword that does a lot of damage by adding more damage points to the damage that my sword class has. So think of class as a blueprint. It's a plan for the thing that you want to build, or that you want to model in your program. And then think of the objects as the specific things that you make from that class. So I'm going to write some code for a short sword that I'm going to say, okay, I'll define my class, and then I'm going to define an instance of that class as a short sword. So I've got class equals sword, and now I've got the instance of that class as a short sword. And then within that instance, I have different parameters set from, say, a long sword or a magic sword. Hope that's not too complicated. Object-oriented programming is something you really have to get your head around. And so let's go ahead and start from the beginning, just building a class, a simple class, and then we'll move on from there. So let's go to the desktop. All right, so here we are on the desktop, and we're going to go ahead and build our, excuse me, we're going to go ahead and, oops, that's not where I want to be. We're going to go ahead and build a class. That's going to be the thing that we start at. So first of all, we've got Notepad++ opened, and we've saved it to exercise 15, which is where we want to be. Let's go ahead and change the directory for our folder, for our code folder. Make sure that number 15 is in there, and there it is. All right, so the thing that we want to do is define a class. It's kind of like a function. We define it outside of the main body of our program. And the key word that we use, obviously, is class. So we're going to define a class, and we're going to call it my class. Now, you don't have to do this in the same text document as your program is in. You can actually create classes in their own text documents should you choose to do that. We're not going to right now, but we will a little bit later. But yeah, you can have lots of text documents, lots of Python files to make up your program. So we're going to call this class my class, for lack of a more imaginative name. And just like everything else, we have to indent. However, we do not have to put a, yes we do. We do have to put a, almost messed that up. Just like we're doing in if statements and any other structure in Python, we have to put a colon at the end of that and then indent. And we're just going to give a variable. I'm going to call it x, and we're going to say it has this value of 5. So that is a class. The piece of data it contains, whatever it's modeling, whatever that x parameter is, it's 5. You know what? Let's do this. Let's do this a little more real world, because this is kind of lame. So let's do this. We're going to go sword. Okay, notice I put a capital letter to start with in sword. In classes, you need to capitalize that. With variables, you don't capitalize the first letter of the word, but in classes you do. And I'm going to change my parameter then. Damage equals 5. Now notice I did not capitalize that. This is a variable name, so I did not capitalize the variable here, but I did capitalize the class. All right, so we've defined our class. Let's move out of it. Start our regular program. Now, in order to use a class, we have to create an object from it. You can't just use the class. You can't just use sword. We need to create an object, a specific sword from our sword blueprint. So what we have to do there is we have to name that. We have to create a variable name for our object. So I'm going to call this one short sword. Notice that I did not capitalize the first letter there. That is in fact also a variable name. And the way we do that is we're calling it kind of like a function. Sword. There are parentheses there because we could have parameters. We'll talk about initializing and we'll talk about arguments for classes a little bit later. But for right now, I have created a specific sword called short sword from my blueprint of sword. So that tells me that right now short sword does a damage of 5. Now I can change that value. I could change that to 10 or 2 or 1,000 or 1,000,000,000 or whatever. And short sword would do that much damage. All right, so I've created my object. That is my object that I created from that blueprint. And now I'm going to do something with it. And I could just print out the damage, but I'm not going to. I'm actually going to do something a little bit closer to real world here. So I'm going to create another variable called health. I'm going to set that equal to 20. And I'm going to say, let's say we were fighting and I hit you with my sword. So now I'm going to say health is equal short sword dot damage. Okay, so what I did, print health. We're going to print the new health. So what I did, I created an object from my blueprint from the sword class. I established the health of a monster. Let's change that to make it more representative. So monster health is equal to that. And then there was an attack here. So I attacked the monster. Boop. Monster health minus equals sword short damage. So like you would do in a game, when you hit something in the game, the monster loses hit points based on the damage of the sword. And so now I'm going to print, let's be a little more descriptive here. Go plus monster health. All right, so let's see if that doesn't do something for us. Let's save it and let's run it. Oh, and I tried to concatenate a deal there. What I need to do is format. I forgot you can't concatenate a string and an integer. So that was a boo-boo on my part. Let's go back and use the format. Remember we said we were going to have to use that? Well, in this case, we are in fact. So let's do that. So we're going to say status is equal to is now okay, and then we're gonna print. Yeah. Format. Health. All right, let's try that and see if that doesn't work a little better for us here. Yeah, I forgot you can't. You can't connect a. Ooh. Did I miss one? Oh, I added an extra one. That's another thing you got to watch is extra parentheses. That's a no-no. Attention to detail is the key to programming. There we go. All right, so the response we got is Monstrous Health is now 15. How do we get that? Well, we built our class up here, the sword, and we said that the damage is 5. And then we built an object from that class. We built a short sword using the pattern of the sword class. And then we established the monster's health. We attacked the monster, which means that we took damage from the sword, subtracted it from the monster's health. And then we established that as a variable. The monster's health is now, and we use the format string function to append the monster's health, or the new monster's health after we took the damage. We use that to append that to our string and print it. Because we can't, remember we had to use the format function because we can't stick a string and an integer together and print them. We have to either have all strings or we have to cast the integer as a string, or you have to use the format method. So that's what we did. So now we have basically a class. Now here, this is a kind of a really primitive class because we can't really do anything else. We don't have a method to change the damage value without having to go back in the code. In a real game, what you would do is you would come along and have a weapon upgrade of some kind, either get a new weapon or whatever, and so your damage value would change. So instead of having 5, you would have 10 or 15 or whatever, and so you would get a new weapon. And that we can't do with this really primitive type of function because we can't change the intrinsic value of damage. It's hard coded into the class, which means every sword we make is going to have that exact same damage. So what we need to be able to do then is modify our class so that it will have a method that will allow us to upgrade the sword's damage. Otherwise, we have to create a whole new sword. And to do that, well, we'd have to create a new class because damage is hard-coded. So, hope that's not too confusing. I know it's kind of a pain, but it is what it is. It can be a little complicated. Excuse me. So, all right. But that is basically, in a nutshell, the way that a class works. And an object is created from a class. Now, we're going to look at parts of a class, some other parts that we didn't really look at. We're going to look at some methods or functions that classes have built in. You know, Python has a lot of built-in methods, like the print method, for example. That is a built-in function inside of Python. It's already there. The code's already written. We don't have to go in and tell Python how to print because it already knows. All we have to do is say print, put something as an argument that it will print, that it can print, and sure enough, it'll pop that right out. But since we just built this class, now we're going to use some other that are built into a class, specifically the init or initialize method. We're going to build that so that we can add further values to our to our class and to our sorts. So let's go ahead and add to this code. We're going to keep the sword. We're going to tab over, and we're going to define a method. And this is going to look weird, but we're going to do 2 underscores, init, 2 more underscores. That's the method description. I realize that's peculiar, but it is what it is. And we're going to do self. It's going to be the name. And then we're going to say damage, D-A-M-A-G-E, and say magic. All right, so we've got a sword. It does damage, and then we can decide also if it's magic or not. And to do that, we're going to establish our variables, and we're going to say self dot damage. We're going to make that equal to damage. Good Lord. And also, don't forget, colon. And we're going to say self dot magic. We're going to make that equal to false. 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 Okay, capitalize. All right, so we have, and we got to tab over. I forgot. Anytime you have a colon, that establishes a block of code. So this method is its own block inside of the class block. So we have interlinked, or we have nested code blocks. So we got a code block here. We have to have colon and indentation. But then the sword class itself is a code block. So we have to have colon and indentation. So as you can see, it gets a little complicated at times. All right, so now let's come back down here, and we're going to reestablish our sword, but we're going to use parameters. We're still going to call it short sword. Say is equal to sword. And we're going to go whoop. And wait. I need to change that. I don't want to set the value here. I want to set the value up there. There we go. Sorry. What I did, I had the hard-coded value set here, which is what we did in the last class. We don't want this to be hard-coded. We want this to be variable so we can change it. These are the 2 variables. These are temporary variables that I'm using. So these temporary variables, I can change them as I go along without having to break the whole object and make a new one. Now here in the declaration is where I'm going to set the value. So the damage I'm going to put here is going to be 10, and it's going to go in the same order as this. Now self, you'll notice that is a built-in variable. I don't have to declare it here. The only words I have to worry about are damage and magic. So I'm going to say that, and I'm going to say false. Okay. So now I have established that a short sword does a damage of 10, and it is not magic. It's based on the sword class. Now, if I come down here, I think I'm just going to print the values this time. So to do that, I can print, and go short sword. say dot damage. And I'm going to print. Notice I'm using dot notation. You should be familiar with this already because we've used it a lot before with other methods. Dot notation is a way that we can use the methods inside a class because we've got the object name which is associated with the class, and then the method or the parameter that is associated with that object. So I'm just going to print off the two pieces of data that I set up here. What it should do is just print off short sword and damage. So let's go ahead and let's save it. And since I'm just printing off variable values and not trying to print off any strings, I won't have to use the format. Ooh. And sure enough, I printed off 10, which is the damage, and the fact that it is magic or non-magic, it is false. It is not magical. So, one more time, let's analyze the code. I realize this is pretty complicated, but it's not that complicated that you can't, if we go over it enough times, that you should be able to get it. So, first thing I did, I defined my class. The class is a blueprint. I called him a sword. So my blueprint here is called sword. Built into every class is this initialize method, and what this does, it allows me to add values. And so now I've created two values, damage and magic. The self basically identifies where these two values should go, to what they belong. So self is the sword class itself. Self.damage is equal to the damage that basically is just a variable because I don't put the actual values in until I call the class creation, until I initialize my class is what we're doing here. That's why this is called an init method. And so I say I assign the damage value, this temporary variable up here. I say that my sword damage is equal to that variable, so that whatever I put in there when I call it is going to go in as damage. And the second one, magic, I say that that is assignable as magic. That variable is that temporary variable is what I'm going to use to establish the magic value of my sword, whether it is or is not. Okay, so I've established my function. I used the right indentions, and I used colons after each definition line. Now in my regular program, I create an object. We call it short sword. It is of the sword class. The parameters that I need are damage and whether or not it's magic. So I establish that. Then I print those values back. Now let's see if I can change them. I'm not sure I can do this because I think I have to build a method to change it. But I'm going to try, and I'm going to say short sword dot damage is equal to 15. Print sword. So I'm going to try to just change it like that. I don't know if it will let me. I think I have to build a method up here to do that, but maybe not. Let's see. And sure enough, I can change it. I thought maybe I could, but I wasn't sure. So we started off with the value of damage for 10 for my sword, and then it's not magic. But then let's say something through the course of the game happened and my weapon got an upgrade. It got dipped in a magical pool or whatever. And now my damage went up by 5. So now this short sword has a damage of 15 from now on until we change it again. So that is the magic of classes and objects, is you can modify them during the program. I didn't have to go back up here and tell it that it had a new value. I just told it in the course of the program running has a new value, and then when I printed out, sure enough, it did have a new value, and so that new value is being used now for anything that may, call it, that may happen. All right, so now we're going to look at one more built-in method. That method is the string method, or the string function. What it does, it allows our function to identify itself. It allows it to identify itself in a friendlier way than what it ordinarily would. So I'm going to build a new, let's see, how do I want to do this? Oh, no, I'm not going to do it. I'm going to leave it just like it is. I've established my sword here. I built the sword, and now what I'm going to do is try to print the sword. I'm just going to print just to see what would happen, what it prints out. So when I save it, all right, and so there's our original damage. It's not magic. There's our new damage. And then we get this main sword object. Basically, that's the memory address in RAM where our sword object lives. So that's what happens when you try to print an object, is it gives you by default, it gives you the address in the RAM where that object is held. All right, so what we've done here is we've established our initializing method. We're going to go with that, but we're also going to define our string method. Same way, 2 underscores and the word string, str, well, abbreviation string, 2 underscores, and then for our parameter, we're just going to use self. Okay, that's a built-in parameter, and a colon, drop down tab. And so what we're doing is we're defining self. We're going to use the return keyword that we learned the other day. And we're going to say self dot damage. And what else here? Self dot magic. Doot. Okay, and what that should do is it should, when we ask it to print this time, when we ask it to print the name, instead of printing that memory address location, it should return these 2 parameters. Now, obviously, what you would do is you would probably not use damage and magic. You would establish a name. In fact, let's do that really quickly. Let's just name. We're going to establish a name for the sword. So self dot name is equal to name. Okay. And so down here, we're going to. All right, now we have 3 parameters. 1, name, damage, magic. When we call it, we have name, damage, magic. So we're going to change this to name, and we're going to change this to damage. So that's a little more accurate representation of our class. So that's what we're going to do. Now when we print it, it should return those values for us. So let's go ahead and save it, and let's see what we get here. All right, and sure enough, it did exactly what we expected. It said the original damage was 10. False is magic. It's not magical. We changed the damage, just assigned it a new value through some kind of sword upgrade, and then we ask it to identify itself. It's a short sword, and the damage is 15. So essentially, that's what we expected it to do. It's a lot more useful to have this information than it is to have the memory address. So that is essentially why you would want to use the string. What that does, that establishes how the object will represent itself in a string if you ask it to print itself. That's why they call it the string function. All right, so basically we've got parameters that describe our class. But then we have another thing that we can do. We can add methods so that not only can our sword do stuff, not only can our sword have values like damage and magic and whatnot, but it can also perform actions. And so essentially what we want to do is we're going to establish another, this time instead of establishing a parameter, we're going to establish a method. We're gonna let our sword do something now. To do that, we have to establish a function. And basically, we're going to call this, let's see, strike damage. Say strike damage self, and we're going to say okay. Kapow. Now we need to use the format because we're going to have to. Okay, so we're going to use the format. So we're going to say strike is equal to kapow. You for damage. Okay. We're going to print dot format, and we're going to say damage. Should do it. So we're going to come down here and we're going to call our method short sword dot strike damage. All right, let's see what happens. Hope I spelled everything right. All right, so there's original damage, it's not magic, new damage, and then we hit something. Kapow, I hit you for 15 points of damage. And then it printed out its identification again. So basically, that is how we can establish methods or functions inside of a class. So now every short sword, or every sword rather, that we build with this class, whether it's a short sword, long sword, or whatever, it will do the same things. In fact, let's go ahead and let's print a new sword. I'm just going to copy this code. This lesson's going to go a little long, but that's okay, because we need to get this down. All right, long sword. It's a long sword. It does 20 points of damage. Still not magic. All right, and so we're going to, just like we did, it's going to have the same parameters, it's just going to use a different name. How about that? And we're going to make that 25, so it's going to get an upgrade. Wow, not 215. It's going to print the new damage, and then it's going to have that same strike method, only it's going to hit for a different variable. So now we have, and we want to print it, and print its identification out as well. Okay, so now we have two swords in our game. Short sword and long sword, both built from this same sword class, both from the same blueprint, two separate objects, and that is an important thing you need to get. Two separate objects. I could have 1,000 separate objects, 1,000 swords, all built from the same class. They'll have the same basic functionality, but they'll have different parameters and different names. So now if I print that, if I run it rather, alright, so first object is a short sword, does damage of 10, it's not magic, we upgrade it to 15, and then we hit something, I hit you for 15 points of damage, and identify myself as a short sword. Long sword does 20 points originally, it's not magic, we upgrade it to 25, kapow, I hit you for 25, and now my new name is long sword. These are two separate objects, they can act independently of each other. They are built on the same blueprint. They have the same basic functionality, like all swords. Swords, you hit things, they have an edge, they cut, they do damage. That's what all swords do. Now, they could be magic, which changes the amount of damage they do, or there's other things we could do with that magical prefix, but not right now. This is just an example. This is not really a game that we're fleshing out. The things you want to take from here, and this is where we're gonna. This is where we're going to stop. We are going to go back to the main screen and talk about this a little bit. Okay, so the things that you want to get from this exercise. The important things are a class is a blueprint. It's basically just some code, makes a framework that I can build objects out of. So a class is the blueprint. The object is the specific thing that I built from that. It's like a house. You have blueprints for a house. I can have one set of blueprints for a house, and I can build 100 houses with those same blueprints. The houses will look basically the same. They may have different parameters. The living room on one may be a little different. The paint in one may be a little different. Things like that are going to be different, but the house is fundamentally a house, and it's the same basic design. Same thing with a class. The sword is basically a sword, but it can have different parameters. It can be long, it can be short, it can do more damage or less damage, it can be magic or not. The thing that's important is they're all built from the same blueprint, the class file. So the class is the blueprint, the sword itself, whether it's a long sword, short sword, or whatever, the specific sword is an object built from that. I have parameters that I can assign in my class. All the swords are going to have basically the same parameters, but those parameters are not going to have the same value. All swords do damage, but a short sword does a lot less damage than a claymore or something like that. So I can have the same parameters, but with different values. Some swords are magic, some are not. Some are long, some are short. They all have different names, but the fundamental sameness is you use them to hit things. They do damage. So I have the same parameters for all my swords, but I have different properties, different values for those properties. And I hope that's not too complicated. I can print those values if I just, without using a string function, without the str function, then what happens if I try to print it, it prints the memory address. But I can build internal methods. There are some that are built in and some that I can design. I have to initialize, or at least I can initialize my sword when I build it, when I make the sword out of the class sword. I call the initialize method. By the way, that init method is in every class, and it is always the first thing that gets called. So when I create a sword, or if I make another class called characters, or if I make another class called houses or whatever, and I create an object, the first thing that happens when that object is created is that init method gets called. So the sword, whatever I'm building, in this case a sword, out of that class gets initialized with the name, the amount of damage it does, and whether it's magic or not. Likewise, the str, the string, is a built-in class, and that lets me identify my object with a little more friendly method than just giving its memory address. Now when I print the object itself, it'll print the name and the amount of damage it does. And then finally, I can define methods like the strike method, and I can say, hey, this is a method that I built. Every time I hit something, it's going to do that little thing that it does. It's going to make that little statement, kapow, hit you for however many points of damage, and it will put however many points of damage the sword does into the statement. And also at that point, I would subtract that many points from the health of whatever I was hitting. So I hope that makes sense, and I hope it's not too complicated. We are going to spend a while working on classes and objects. There are some other built-in methods we need to look at, but this video is probably already too long, and it's modestly, it's not really complicated, but it's modestly complicated compared to what we've been doing. So it's a modestly complicated process, and we need to maybe bite it up in little pieces. So today we learned a little bit, tomorrow we'll learn a little bit more, and so on. All right, so for this exercise, you're going to build a class, and you're going to basically just build it and then build an object from that class, and that's all that's going to be required. So when you get done, your code works as expected, then you're going to use the start assignment above to turn in your Python files. If you have any questions, I can be reached through the Canvas inbox, so get in touch with me, and I'll create a video, or you can come by the office, or whatever needs to be done so that we can get you up to speed on this. So whatever I can do to help, let me know. Have a good day, and I will see you in class.